Hi, welcome back. Today we're going to go ahead and work on through our chapter 5. Let's see if I can make that lock on its focus. There we go. And specifically, we're going to talk about section 5.2. Now, 5.2 is all about division with polynomials. And you've done this before, mostly with quadratics, which you could easily factor. So probably in Math 95, when you did division, you focused mostly on quadratics or on problems that had monomials in the denominator. Things that look like 10x to the 5th minus 15x to the 4th plus 20x to the 3rd divided by 5x squared. And the way that you learned to do these was essentially with an application of the distributive law. You probably remember that dividing by a monomial is the same thing as multiplying by the inverse of that monomial. And so then what we do is we distribute that multiplication all the way through. And we end up with 10x to the 5th over 5x squared minus 15x to the 4th over 5x squared plus 20x to the 3rd over 5x squared. So we really end up dividing our denominator into each term of our numerator. And we end up with 2x to the 3rd minus 3x squared plus 4x. That's great. However, it only works if we have a monomial in the denominator. If we have anything else, something that's got more than one thing down there, then things get a little more tricky. So, for example, if I want to simplify x squared minus 6xy minus 7y squared over x plus y, I really have two choices. If the numerator is something that I can factor, then I factor the numerator. So I happen to know that this numerator will factor as x minus 7y times x plus y. And that's still all over x plus y. Now, once I've got everything in factored form, then I can cancel the matching factors. And I'm left with just x minus 7y as a simplified form. But remember, we don't know how to factor every single polynomial we're going to run into. So we're going to use a couple of different tools. One tool that we're going to use is long division. Now, hopefully you remember how to do long division with numbers, but I'm going to show you how to do it with polynomials. So if you don't remember how to do long division with numbers, look on page 345 in your text, and there's a nice review there. Let's talk about how to do this with polynomials. And let's start with one that we can't factor. So we've got 4x to the third minus 6x minus 11 all over 2x minus 4. We can't factor that numerator. It's a cubic, and it only has 3 terms, so factoring by grouping is not an option. So we have no choice but to just do the division. Okay, so here's what we do. We set this up with a divide sign, just like we would for long division with numbers, because it works a lot the same. And underneath, now, we put our numerator. Now here's the kicker. We have to start with the highest order term and then make sure that every term is visible in decreasing order of degree. So I started with a cubic. I need to have an x squared term. My numerator does not have an x squared term. So I'm just going to put in a placeholder. 0x squared is just 0. We don't typically write it, but there's no reason we can't. Minus 6x minus 11. When we are doing long division, we need to have all of our terms from the highest order term to the constant term present and in order. The same thing goes for our denominator. So our denominator goes out front. In this case, it's just 2x minus 4. If it had been something like x squared plus 3, you would need to put in the x squared plus 0x plus 3. You run those all the same way. Okay, now here's what we're going to do. I want to get another color, so give me just a second here. Grab my green pen. Okay. When we're doing long division, we compare the leading term to the leading term in our polynomial. And what we do is we ask ourselves, what is 4x to the third divided by 2x? And you're going to know that that's 2x squared. We put that result right here. Okay? Now, we take whatever we just wrote down and we multiply it all the way through what we have in front. So that's 2x squared times 2x minus 4. Or 4x to the third minus 8x. Okay, now the next step is to subtract, but I'm really not very good at subtraction. So I'm going to remember that subtraction is the same thing as adding the opposite. So I'm just going to go ahead and I'm going to change my signs so that I can just add. So 4x to the third plus negative 4x to the third gives me 0x to the thirds. These two terms should always cancel if you've put the correct value up here. Now we add 0x squared, and 8x squared, and we get 8x squared. And now we bring down the next term. And we wash, rinse, and repeat. We're going to compare 2x to 8x squared, and we ask ourselves, 8x squared divided by 2x gives me 4x. And now we multiply 4x through by our denominator. And we get 8x squared minus 16x. We need to subtract, but we're no good at subtraction. So we're going to add the opposite. So we change both signs and just add. 8x squared minus 8x squared is 0. Negative 6x plus 16x gives me 10x. Bring down the next term. Wash, rinse, and repeat. Compare the 2x to the 10x. What is 10x divided by 2x? That will be 5. Multiply through, and you'll get 10x minus 20. Change the signs so you can add, and you get 9. This is the remainder. The way we handle the remainder is we come up here and we say plus whatever that remainder is divided by whatever we are dividing by. So my result, my simplified form of what I started with, my 4x to the third minus 6x minus 11 all over 2x minus 4 equals 2x squared plus 4x plus 5 plus 9 over 2x minus 4. Okay, now you may be thinking to yourself, but this chapter is all about solving polynomial equations. This is true. But remember, the only way we can solve polynomial equations is if we can identify factors. So what we're going to do is we're going to use division as a tool to identify factors. Because here's the deal. If, and this comes up later, but I'm going to tell you right now anyway. If we've got one polynomial and we divide it by another polynomial, if this quotient has a remainder of 0, then Q is a factor of P. So, for example, think back to that. We did x squared minus 6xy minus 7y squared divided by x minus 7y, divided by x plus y. And we found out that that simplifies to x minus 7y because x squared minus 6xy minus 7y squared can be factored as x minus 7y times x plus y. If I had done this with long division, I would have gotten a remainder of 0. So the whole math speak thing says that if you can make, So if we write it this way, that P of x divided by Q of x is equal to some other function R of x. This is actually the definition of division. Then P of x is equal to the quotient of those two things. So this is, we know this. 8 divided by 2 is equal to 4 because 2 times 4 is 8. Those same rules work for polynomials. Okay. Now, there is a shortcut way to do division, but it's pretty limited, and I'm going to talk about that in a separate video. So we're going to stop here for right now. Let's do a quiz. This is quiz 6. And I want you to simplify, in other words, do the division So maybe I should just say that. I want you to divide x squared, 3x to the third minus 5x squared plus 2x minus 1 all over x minus 2. And you guys know the drill on these by now, so I will look forward to seeing your submissions, and I will talk to you again very soon.